So hello everyone, my name is Shreya Agrawal, and on behalf of PyBerlin, I welcome you all to this event. It is our spring event, our 27th event, and the sun is shining outside, the flowers are blooming, and we're very happy to be able to host this event, albeit on Zoom on video. We wish we could do it in person, and looks like if the lockdown is eased or things become better, we will be able to do it in a couple of months' time. But till then, let's have it online and let's meet each other here to exchange ideas on Python. So why PyBerlin? Well, PyBerlin is an aggregation of two words, Python and Berlin. And Python, the snake Python, climbed the TV tower and was very excited to be here in Berlin and thought, why not have a community that interests both Python and Berlin people? And so that's why we have this community of PyBerlin. We all love Python. We love sharing ideas. We're based in Berlin and we welcome everyone who is interested. Our organizers are Anesthesia, who is managing the whole Zoom platform and has managed this setup and is working very hard to make this event, all these events possible. Myself, Shreya, and Theo, who you will be speaking with in the later part of the event, and Lubin, who all four of us together really work hard together to make these events possible. And we're very excited to do this as well because it helps us stay connected with the community. Thanks everyone for joining. This is our 13th online event. We started last year in March, I think, March or April. And since then we've been organizing events every month. And we are so happy that we've been able to do this every month. And we don't have many rules as such or any strict guidelines, but one thing that is super important to all of us, both our organizers and our attendees, is that we be nice to each other, be a little bit patient. Sometimes technical issues can happen and it can happen with everyone, so be patient. And also when you interact with one another, just be nice and be welcoming to all ideas and all backgrounds. If you're interested in more guidelines and code of conduct, you can find the link on our screen and you can read it over there. It is very safe to ask questions. So no feigning surprises or well actuallys, no isms. By isms, we mean racism, sexism, or any form of discrimination. Please be very welcoming and welcome people with different ideas and have a debate, no doubt, but be respectful to each other. So today's event is sponsored by Sql, and Anesthesia made it possible to connect us PyBerlin with Sql. So thank you, Sql, for sponsoring this event, for sponsoring the Zoom platform, and Anesthesia for making this possible. So today's agenda, we have two very interesting speakers lined up for today. First is Cheuk, who would be talking about batteries included, things you can do with standard libraries. And second is Gerald, who will be talking about coronavirus, computations and plots using Python notebooks in Google Colab. So very interested to hear more about both of these sessions. So stay tuned, and soon we'll be starting with our first speaker. But before that, we have one very interesting announcement. So we are collaborating with Manning Publications, and they have decided to do a raffle. And the winner of the raffle will be chosen randomly and will win one free book on deep learning with Python. To enter the raffle, you can see the link on the screen, which will also be posted in the chat section and also on our Twitter page, or you can scan the QR code visible on the screen and enter the raffle. It is a very good opportunity to get a book. Deep learning is so interesting these days. So don't forget to enroll in the raffle, and who knows, you can be the winner. You will need to provide your name and email ID so that once we decide the winner, and if you are the lucky one, we can get in touch with you. So please do make sure that you participate in the raffle, and we will be announcing the winner by the end of today's event itself. So go ahead and enter to win. On another note, we are also looking for organizers. So if you're interested in organizing this event, right now it's online, but soon we are hoping that this will also be in person, then you are very welcome to join us. We are looking for someone who can help us in handling especially the social media platforms such as Twitter, LinkedIn, and all those other social media platforms to spread more awareness about Python and Python community in Berlin. So if you're interested, then please reach out to us on Twitter, on Meetup, or individually as well, and we will be more than happy to have you. Since it can be both online and offline, whatever works for you, and we will make it possible according to mutual convenience. Also, we're looking for speakers, and we would be very happy if you decide to share your idea or project on our platform. When I say speakers, do I mean just professional speakers? Well, I don't think so. By speaker, I mean anyone who wishes to share something related to Python with a wider community. You can even use this platform to practice your communication skills, presentation skills if you're preparing for a bigger conference. And we would be very happy to have our community listen and give you feedback on your ideas and project. We have two formats. That is one, the standard format of a 30-minute talk with Q&A, and then short talks of 5 to 10 minutes that are more of a lightning talk. And this can be with or without Q&A as per your preference. So if you're interested, we are looking for speakers. So please feel free to drop us an email or message us on Twitter, Meetup, or contact the organizers individually, and we will make it happen. If you're interested, you can also use this QR code to submit your proposal, and we will get back to you very soon. Our next meetup is also decided. It is on May 24th, 2021, actually, not 2020, and it's on Monday. Our speakers are also decided, so please block your calendars. We will also send you a reminder as we move closer to the event, and we will be very excited to have all of you for our May event as well. It is an online event for now, so you can even join us remotely, and we will be very happy to interact with you once again in May. Also, we want to know why you like or dislike PyBerlin. And if you want to connect with us on Twitter, our handle is PyBerlin Python. So throughout the event, if you would like to tweet about what you liked or what you would want us to have in future, then please tweet about it or reach out to us. And if you tweet about it, then please don't forget to tag us with the handle PyBerlin Python. We also have a Slack community at Berlin Python Community Slack at pythonberlinslack.herokuapp.com. So please join there. People are very interactive and posting new ideas very often, so you can stay connected with the community if you decide to join our Slack community. And one huge shout out to those people and platforms who made all this beautiful platform and logos possible for us. The free assets and resources were provided by Slides Carnival and Unsplash. And people who help with the logo and story are Elena, Konstantin, and Christian Barra. So thank you to all of you and the platforms for helping us create this platform and slides and the assets. We've been using it for almost 2 years now, and we are very grateful that you all took the initiative and the platforms provided us with the necessary information to create this. And with that, we welcome our first speaker, Cheuk, who will be talking about batteries included, things you can do with standard libraries. So Cheuk, over to you.
Good. So thank you so much for having me. This is a brand new talk. So it's more like I would say that for people who are new to Python or doesn't know that these things exist, I would basically talk about standard libraries, which everybody should already have, because if you install Python, you'll have the standard libraries. I'll give you more details in a bit. So I'm Cheuk, self-promo time usually. So I have worked in the open source kind of space for a while now. I have some of my personal projects. Now I work full-time for TerminusDB, which is an open source graph database. So if you're data scientists, data people, feel free to chat with me, and we can talk more about databases and all this stuff, because I'm now a database nerd. So also I like organizing events, different events that bring Pythonists together. So there is a Python sprints that, I love sprints, so there will be more coming up. There will be mentored sprint in different conferences. EuroPython is happening in summer this year, late July, and also other conference would be happening as well. Also, by the way, EuroPython have a mentorship program for first-time speakers. So if you want to speak, you can, of course, speak at a PyBerlin as a practice, but also you can try to find a mentor and, get the support from EuroPython by going to EuroPython and then sign up for the program. Also, I stream on Twitch. So yeah, I've seen there's some chat there is bothering me. So yeah. Let me check. Yes, so there's a Heroku out there. Okay, fine. Going back to the slides. So yeah, I stream on Twitch as well, so you can follow me and have a look at my tutorial if you want to. And so the story started why I am interested in the standard library. Well, actually, like we have always been, subconsciously using some of the standard library without really knowing them, because sometimes, for example, you have a challenge that like, oh, how can I do this? How can I do that? You look for an answer. You came across the solution on Stack Overflow, and then you just like, oh yeah, do this, just do this, do that, right? And sometimes the solution actually use standard library, and you just, copy the code, import and then put it there, and you without realizing that, oh, actually, for example, if the solution tell you to use, let's say the syst, SYS, the standard library, you're just like, oh, import sys, but like you have no idea why you have that, right? You'll be like, when did I install it? I haven't do a pip install or anything, but that's the standard library. But it actually come into the spotlight from in my life when I was working in the bank. So at that time, I was like put into this job that I was told that I'm doing Python programming. I was put to my desk first day of my job, and then logged in, set your computer up, everything. This is your laptop, logged in, and okay, we have a Python for you. It's a Python 3.6, but that's all you got. So okay, first thing like everybody else, oh, I need to use pandas. I was it was a data science position, so I install, I want to install this stuff, right? I want to do all the pip install. So, but the thing is that when I run pip install in the command line interface, it gives me an error. It says that I can't download the libraries. It's because it's a bank, and like all the information that a bank got, of course, is very important, right? So there are actually security measures that are set in the system that we can't actually, download anything from the internet. Like if you want to get something installed on your laptop, actually you have to go through a process of, I think some of you may know, if you have worked in a big organization, you have to get the IT team's approval and all this stuff, so they would install it for you. It would take weeks or a month to finish. And also the limited access on the internet where you can search for stuff, but sometimes even GitHub, I can't access it because they worry that you upload something that you shouldn't. And you can't use your phone or laptop even, like in your work, your workstation. So it's quite straight. So there's a lot of challenge. So what should I do? So, well, I better get myself familiar with the tool that I have, right? So that's why I look at what I have, and I do have the standard libraries, and I don't need to pip install the standard libraries. Like I said, they come together with your Python installation. So probably the person who set up my computer download like Python 3.6 from the official, python.org website. So that's the official Python interpreter installation. So all the standard libraries come with it. Well, actually, if you're using Conda, you will still have it. But if you're using Anaconda, of course, you have more than just the standard library. But yeah, I wish they gave me something with the Anaconda, right? But they didn't. They just like, oh yeah, this person is doing some Python job. They don't know about Anaconda. They don't know that I'm doing data science work. So yeah, they just give me a Python 3.6. So yeah, standard libraries. You have it already. If you're curious, you can actually now just go, to check it out yourself. So there's according to the official documentation on the official website, there's actually, I'm getting blurry here. That's fine. So yeah, so according to the actual website, there's actually two types of standard libraries. There's one type that's written in C. So if you being very nosy, right? If you dig down the source code of the Python interpreter itself, which is CPython, then you look at some of the things actually is written in C, right? So those are including some standard library modules that actually they're written in C, because they are more low level stuff. You may have to work so it needs to work with your system. So to able to like, work with all these like system functionalities, like to go into those low level things, you have to use C for those access. So those are written in C. But there are actually other modules that is written for doing some task easily. So for those things, you can write your own code to do it, right? For example, datetime, you can create your own class of like data object, have your own, way of dealing with a datetime. But well, why would you do that if there's someone already written it, and then you can reuse the code? So it's the same idea as those things that you pip install, but this one, because it's so common that Python, the community decided that they should come in every single installation. So our math, is very common as well. You can't avoid some kind of mathematical problem at some point. Especially when you're doing data science work, datetime is very common as well. Not just data scientists, but also people who are maybe doing system admins and other stuff. Datetime is very important. JSON. JSON is a very common format for different programs to to communicate, right? You sometimes you send a JSON through API and all this stuff, so it's a very common data format. So that's why it's included. You can find a complete list via the link here. And you can see that there's so many. I'm not going to go through them one by one, but I have some highlights for you. Basically, those that I found quite interesting and quite useful for some of you. So first of all, so go back to my story. So I always, when I'm working with my personal projects, I love using a virtual environment. So it became a habit that, I would set up a virtual environment for a different type of project, even for a data science project as well. So I want to set up a virtual environment. My normal tool will be PyEnv virtual env. So PyEnv and virtual env are two things, but there's a virtual env plugin for Python, so I just all the time I use them together. So PyEnv let me to use different versions of Python in my machine. I can easily switch between them. Virtual env just basically create a different set of libraries that in different virtual environment you will have a different set of libraries, so you won't mix and match. You can pin the version number and make sure that so you don't have to reinstall everything again if you switch project. So what can I do with that? Well, there's actually something that comes with Python, and that's why I think no excuse of not using a virtual environment and mess with your setup. You should just use venv. It comes with Python, and it works quite well. There is a different code. So this one I'm showing here is, you can actually look at the documentation. So it will show you more details and every stuff, but this is just an example code I put here, how you set up a virtual environment by just doing, running venv as a module in Python. So, so in case you don't know, if you type Python or Python 3, it depends on which version of Python you're using and whether you have both 2 and 3. I think now it's more common, people just use Python because 2 is slowly retiring. So if you type that and then use -am, means that run the following as a module, and then venv is the module. So it would just, so you can actually do that with pip as well. You can Python -am pip and then install, just use it like a module. So yeah, there are chances that you can just type venv, but the more secure way of doing that to make sure you use Python 3 is to do this, like Python 3 -am venv, and then the command for venv to set up a new environment is the tutorial. Like, this is the name of the environment, and then after that you have to activate it. So to do that, you have to source. So actually set up a bin for you in the tutorial environment here. You can change it to the name of your own. Yeah, you can change it to the name of the whatever you want to use, and then it will set up the bin. So there's the activate code in there, so you just need to source it, and then you would create a new environment in your in your command line, and then you can just do it like PyEnv activate. it's the same thing, or conda activate if you're using conda. So this is quite good. So it's useful when I'm running workshops as well, because where everybody has VM, right? There is a slight difference. So this actually command is for a Unix system, which is Mac and Linux. For Windows users, there's actually a other way to do it, because it will set up a script called activate.bat. So you need to run this script instead of use the source in Unix system. So yeah, you can find all the details in the documentation. So I'm not going to go through them in details. So yeah, CSV files, data scientists, always 99.9% of the time you will be given some CSV files. You have to work with them. Well, of course, eventually I still have to use pandas. Pandas do a lot of things that I really need it. I feel like I have like one arm broken if I can't use Panda. But while I'm waiting for people to set up the proper thing for me, I can use I can still open a CSV file and have a look in it, and just do some simple thing with it. It's more clumsy than Pandas, but it's still, you can still open. It's better than just reading it as a text file. So there's this CSV library that you just import CSV and then open it. You just read it like reading any text file, but with a CSV reader, you can set up the limit. How do you pronounce this? I see this word so many times, I don't know how to pronounce it. And like just the separate, what is the separate characters, right? You can set up all these things. And, what is the new line? You can actually, if you look at the documentation, again, all the details are in the documentation. So you can actually set that up. So instead of reading it line by line, and then you have to do the the string and then do the split yourself, it will just split it up for you. So it will become so each row actually become a list, and then in the list there's different elements in the different cells. So which is quite good. So it's better than just it's your best bet without pandas to read the CSV file, I would say. You can also write it back as well. So yeah, you can write it back. I know this is a bit small for you. So yeah, so when you read it, it would actually just become a list. So you can join them together. You can write it back as well. So you have, again, just like a reverse direction, right? You just have a list of things, and then you can just set up like, how to separate them in the CSV file. So or there's also some other like stuff that you can do as well. You can make it into a dictionary. So this is more like a pandas, I would say, that if you read it as a dictionary, you can have the column name and stuff. So which is quite good. So yeah, like if you don't have pandas, that's your way to go. So. And then work with SQL. Again, like data scientists always, not always, but most of the time you work with a SQL database. So I use SQL Alchemy quite a lot. It has quite a good interface to work with SQL databases. You just hook it up with the driver and all this. But yeah, but if you're using SQLite, you're lucky, because there's actually in standard library, you can just use SQLite 3. That's like that easy. You just, it works just like SQL Alchemy, but you don't have to hook it up with a driver, because it just have an internal SQLite driver, I guess. So so yeah, you can just connect it to the database and set up a cursor and execute a SQL query. And yeah, so you can just commit your change, and then you can close the connection after you're done. So I don't know what else to add. It's just something that you could do actually, but most people don't know about it. That like you think that you need some fancy setup, but actually, if you're using SQLite, that's the easiest thing you can do. Another thing, request, is it with an S or not? I don't think there's an S, but yeah, request is a library that lets you do all this API calls. Most of the time you're doing API call, but also you can use it when you scrape a web page or something, that you can just get the HTML from a web URL. So, so actually there's a URL lib that actually provide a lot of things you can do with the internet protocol and connection, all these things. inside there's actually a request library that do most of the things that requests do. Not all of them. It's also said, yeah, there's an S, there's a typo on my side, sorry about that. So the request package is actually it also recommended if you have more complex things, or you don't want to mess with the low level stuff, you can actually, it's a more high level. That's why it's popular. But if you don't have requests, then you can actually use a URL lib.request. It do most of the things that request does. You can actually, make an API call, and then you come back with a response object, which you can see the status code, and you can also get the content of it as well. So yeah, again, I won't go through all of this. You can check it out yourself. But I guess this one is more common. Most people know about this one because a lot of Stack Overflow solution actually mention URL lib. One thing to notice is that Python 2 and 3 is hard to use. Yeah, it's a bit hard to use, but it's that's why requests. I use requests because it's it's high level. It's easier to use. But if you don't have it, then your next best thing is the URL lib. And the troublesome thing is that because if you look for how to use things in URL lib, because the version 2 and version 3 are quite different. They have a big reconstruction of the library. So sometimes you find a solution and they didn't explicitly mention it. And if you're not familiar with the library, you copy some code which is meant for Python 2 and then you run it, it doesn't work. So that's why it's quite confusing if you're trying to use it and find some information on the internet. So make sure you type Python 3 when you're looking for URL lib. So yeah, that's the only catch here, but it's quite powerful. It can do a lot of stuff. This is not the only thing, because like if you look at the list, the complete list here, you can see there's quite a lot of things in the URL lib. You can see there's a pass and error, and there's a response object. Yeah, this is what I mentioned, and then you can have actually headers, just like the response object in requests. So it's very similar. Very, very similar, but a little bit more clumsy, but yeah, it's still good. So yeah, unit test. Everybody should write unit test. I always say that, like to new programmers, that test is very important, because without test, you never know when you're working a big project where your code is broken down, if someone else touches your code, what went wrong and all this stuff. So unit test is needed most of the time. I use PyTest personally. It's the thing that I use to, just no brainer, set up a new project and then, okay, PyTest is needed. But if you don't have PyTest, you can use unit test, which is a standard library in Python. It works more or less the same. It also have all these decorators that would, that you could do this as well. So like in PyTest, you can skip the test, you can exfil, in PyTest, you can say that, oh, this test is failing because I haven't fixed it yet, or it's meant to be failing because of some whatever reason. But you can skip the test as well in unit test. It also have all these things with like mock, patch, all this stuff. You can still do similar things like PyTest. So it's just that the when you run the test itself, because I'm used to PyTest, I like how they color code it and how they error report and all this stuff. But it's highly similar. Yeah, you can fixture all this stuff. It's just like PyTest. So yeah, you can just, this is super similar. I don't have anything more add to that. If you have used PyTest, you won't feel that unit test is alien to you. But I just like the output. This is the output of the test. I just like the output of PyTest a little bit more. So that's that. But you can use it if no excuse of not running tests anymore. So there's also other things in Python standard library that I quite like. So I want to share it with you as well. pprint. This saved my life. I work, so now I basically maintaining the Python client of TerminusDB, which, because we use JSON to pass the information to the back end. So there's a lot of JSON. I need to deal with lots of them. If it's like, so it's actually a dictionary that I construct in Python. So if I just print it out, it would be like this, right? It would be just like what is this, right? It's just, this is a whole line. I just wrap it so you can see it better. So it's like, when you print a complex library, like a dictionary, it's like, I can't make sense out of this. But on the other side, if you use preprint, it will be, it will have indentation. Thank God you have indentation. You can look at the dictionary and then look at, oh, what's the wrong with it? Am I sending the right thing to the backend? All this stuff. It's much easier to debug. So ice cream, someone suggested something for me. Thank you so much. I'll check that out in a bit. Sorry, typo again, because all these slides are new. So yeah, you can also format the output. So if you don't like it to be so narrow, you can also format, okay, maybe put 3 elements in a line, don't break the line for every single element. You can do that as well. So preprint is quite good if you're dealing with complex data in a dictionary format. Doc test. So doc test is actually something that I should use more. It's useful when you have documentation, and then if, for example, if someone contributes some documentation for you, they will add some example in there. That for example, like here, these are docstring, right? So everybody should be familiar with docstring, because these this lets you write documentation with your Python code together, so you can maintain them easily. So you have some example there, right? So you'll be like, okay, this is how you use it, and then this is the expected result. So if you run doc test, it will just test all these examples for you to see if the expected result actually is the correct expected result. So if someone contributes some documentation for you, you can do this to check that, or whether the examples are correct, because you don't want your documentation to be misleading for users. So yeah, you can just run it. So yeah, you can use this doc test to run it, and then you can yeah, we just like run all of them and then trying, and then see if the expected results are correct, and it would just give you like, okay, so what how many passes and how many fails. Just check all of them, of the code there, and then yeah, some of the Py works like magic. Yeah, so actually you just use -v, and it will just give you all the things. Yeah, you actually have to use those -v, because if you pass, then it would just like give you nothing. You can trace it. So yeah, you can actually also run doc test, not just in your docstring. You can also run it with some text file. So like this. So actually that's quite nice. You have like, if you write a blog post, right, you can actually run the doc test on your Python code, and it's crazy. So yeah, but this is just like an example here, an example module. Yep, of these, just quite good. It's something simple, but it's people overlook it, right? So because you didn't use it that often. PDB, okay. When I discovered PDB, I was like mind blown, because when I first learned Python, how do I actually, like, I think most people, 99.9% of the people who are new to Python, would just print the results when they debug, right? I still do it sometimes, I have to confess, to just check like, okay, whether, this variable, whether it's like holding the value that I'm expecting it to hold, right? So you just print it like everywhere you have some print, and then actually like some linter will pick up all this like print function and say like, oh, you have a print there. Did you forget to delete it after you have run some test or something? So yeah, it's quite embarrassing if you kind of have some output there, and yeah, if you run some, if you forgot to delete it, it's quite embarrassing, because when your user is using your library and then suddenly it's print out something in the standard output that it's not expecting, which is quite bad. So it's not the best way to debug your Python program, actually. So there's actually a debugger, a Python debugger that is come with your Python. So yeah, you don't have to, most programming language you have a debugger, but Python it come with it. It's called PDB. So what you need to do is to, instead of adding print, you just add this line, import PDB and then semicolon pdb.set trace. So what it does is that your program will run, and it will run to this point, then it will just pause. So you will have this like interactive debugging thing here that you could actually, or if you want to keep on running to the next line, then you can type continue. But if you want to print out some some kind of, you can check the variables in it. You can check, like, for example, I have user input. What does the user input? You have no idea. You want to check it out, then you can print it. You can just, you have this like PDB thing here, and then you can just type whatever. It's useful when you have a dictionary. You want to check what's inside a dictionary instead of printing all the elements or printing a big dictionary. You can just like interactively go through the dictionary and check like, oh, what's inside? Is that the dictionary? That anything wrong with it? Is it holding the expected value? What's wrong? So PDB is quite useful. I use it quite a lot. There's also something called IPDB. That's the counterpart for the IPython. So if you're using IPython, interpreter, then maybe there's IPDB that you want to use. It's just that the coloring will be different, but I don't mind that much. PDB is good enough for me. Okay, so this one is a fun one. So Turtle is most people don't use Turtle because it's meant for kids. Again, like I only know about it when I was actually teaching a workshop that the person who set up the materials was so it's using Turtle. I was like, oh, what's that? And then I look at it. It's like, oh, actually, I do have Turtle. Everybody have Turtle, like Turtle inside their Python, because it's a standard library, and it's meant for teaching kids, how to draw, how to program. Because what this code does is that it actually you can select the color, and then you can say that, oh, do you filled it up or not filled it, and then you move the turtle. It's like a cursor that you move like forward, turn left, turn right, you can pen up, pen down, putting it up and down and draw something. Yeah, you can do some awesome project with it actually. So yeah, but I'm quite surprised that actually you can think about, okay, there's a useless module in my Python, but actually it's not that bad, because it just shows you that Python has the beginners at heart, right? It have educational value in its like implicit educational value in Python. So that's also, I appreciate how Python could be an educational tool for kids to like doing professional stuff, doing async, doing all this, web development and like all this data science, machine learning stuff. So yeah, this is something that surprised me when I first learned about it, but now I appreciate it. So other stuff that you may have used before, Timeit is very useful, and I think some data scientists know about it. You can use it in Jupyter Notebook with the magic, but you can also use it in your standard Python. Just time whatever process you want to. Just check whether it's take forever to run, which part of your program is taking forever, right, basically. So processing is let you run some shell stuff. You can, well, there's also syst and, OS for you to use, but sometimes, for example, I don't know how, but like, for example, I want to run curl instead of using request. Then you can use a process to run it. You can also use a process to run Docker. That's something that, well, Docker has the Python client, but sometimes you just, well, I'm just lazy. I just use a process to run Docker, XML lets you to read, write. I don't know why there's a slash here, again, typo. Read, write XML files. So yeah, I occasionally need to deal with XML files. So that would be handy for me to go through the structure of the XML. Async Io, so async stuff, if you're doing async, like writing a Discord board, that's what I do async with. So there are some useful stuff in it, like the event loop and all this thing. Import lib, recently I'm looking in it because I'm looking at like how you can dynamically import a module instead of typing import at the top. So you can actually inside a function that you could be like, oh, if I run this function only at the time that is, then I import a module. So it's like call upon request. So I don't have to import a module every single time. The user just run the script, because if they don't, for example, if I have a library that, well, if I use one part of the library, then I may not necessarily run the other part of the library, right? So if I'm importing something that's very heavy, it may not be a good thing, or something that takes a while to import, then it's not a good thing. So I want to import upon request, then I can use import lib to do that. So basically, it's everything that you do with import actually is here in the import lib. RE, I think most people know about this as well. Regex, so lets you to search for some text inside. You can use regex to find the matches or this stuff. File compare to file. So it's quite useful if you, for example, have two CSVs. Again, you want to check whether they are the same file, or actually there's some changes in it. There's a new version. So instead of doing it like, writing a program to import them line by line, you can just call a file compare. So I think this one is model level. So it doesn't do it in, in Python, it do it at a model level stuff. So it's faster. Other stuff that I haven't used, I want to try would be there is a GUI tool. I know that most people who write a Python program like that have a GUI interface won't use this one. I forgot which is the I think it's Qt, right? Qt is the popular one that people use, but actually it's the built-in modules that let you do that. So I guess this is quite difficult to use, but I'm happy to have a look at it and see what they provide. Also, parallel things that I've never touched that part of. It's web-based GUI too. Oh, okay, yeah, yes. There's a lot of GUI too out there, I'm sure, but yeah, actually, I'm quite surprised that Standard Library has one. So it has this in mind as well. Like Python is really for everything, right? And also parallelism. There's this like threading, multiprocessing. That I've never do that. I've done a little bit of async, but I've never done parallel multiprocessing, all this stuff. So these two are a little bit different. It's at different level. Parallelism, I have no idea what they are. I'm yet to learn them. So yeah, you can tell me more about them if you're an expert in any of these. So that's the end. So which one is your favorite? Let me know in the chat, or ask me anything about the standard libraries. If I have used them, if I know them, I can teach you, but it's so huge, so I can't teach you everything or tell you everything. Or you can tell me something, So yeah, thank you so much.
Thank you for the insightful talk,
yes,
Cheuk.
Thank you. Turtle is quite nice. Preprint, yes. Really, it's very useful. Preprint, yes. Yeah, so any questions? I think there's a break between the two talks. So yeah, I'm just bringing my screen down so I can look at the chat more properly. Oh, what I have missed it in my presentation, right? In Standard Library. Or do you mean like what I want to add to the Standard Library?
You can also unmute and ask a question.
I have no idea, actually. I think the Standard Library list is quite complete at the moment, but if there's one thing that I want to add in the Standard Library, I think would be something like NumPy. It's like I can't find something that do linear algebra that well. So yeah, NumPy is quite good, and the mathematic things in Standard Library doesn't cover that area. So yeah, maybe that one. So imagine if NumPy is in Standard Library, you can actually write a neural network. You can write a neural network with NumPy with some effort. So you can actually, like, if you can write, neural network and machine learning in Standard Library, that would be crazy, right? So yeah. So what's the thing? Why on earth would anyone need this? I think that I don't know, because like the thing is that there's a lot of things in Standard Library that I was like, why is in the Standard Library? Like, but I think that there must be someone who need it, right? If otherwise they will be taken away. So I don't think that, why on earth? But like, I was just like, oh, okay. So I would think like, who would actually use this? And some of them like are for a Unix user. So there's like something that's basically mainly work with Unix. I think those would be the one that I may not be using as much, even though I'm using Mac, but I think I rarely touch those things, right? Like POSIX, those kind of crazy stuff that I never. Yeah, func tools are good as well. Data classes, yes, those are more like for more advanced Python users. It's a tool, so let you have more control over the Python behaviors, I guess. Oh, it's not. Oh, so it's about the GIL thing. Okay, yeah, I'm not so sure. Yeah, I have to learn more about those actually. Yeah. So there, yeah, func tools, iter tools, data classes. Yeah, I didn't include them because I know that advanced user would be familiar with them because you have to use them. Also typing as well. Typing is something that, you know, that a lot of people use if you are very strict about your typing in your code. MyPy, MyPy is an interpreter. It's not a standard library, isn't it? Yeah. Yeah. Diplomatic. No, not really. Not really. Yeah. Yeah. That's I think that's it. We'll have the next talk at in 10 minutes, right? So maybe we can have a break. I don't know. Any organizers can give us a clue.
Thanks for the talk, Cheuk, again. And there is actually one more question from the Twitch stream. Is there a big change in Python 3.8 regarding standard library?
Is it big change in Python 3? 3.8?
In Python 3.8.
There is some changes. I think you have to, the best way to find out is to look at the release note. I think there's one that's called the import lib has some changes that really like they really mess me up when I release something because my library support 3.6 or above. So so some like I think one of the libraries that you know, they forgot to cover that change, and then I got a weird failing for just 3.6 and 3.7. So yeah, so import lib has some changes, but I think if you want to be sure, you check the release note of Python 3.8, then you can see all the stuff. Then you know how to be careful about your release. I guess don't make my mistake. Yeah.
So let's welcome Gerald Schuller. He's joining from Germany with a great talk, which is called Coronavirus Computations and Plots using Python notebooks in Google Colab.
Great. Yeah, thank you for the introduction. And also I would like to thank the organizers for organizing those nice PyBerlin talks. I'm looking forward to every one of them. And I think particularly in the pandemic, it's very nice to have it online. And also the online format has the advantage of having a wider reach, like across all continents. So that's kind of an interesting effect. Okay, so let me start with sharing my screen. So, okay. Can you see my screen?
Yes.
Great. Yeah, so my name is Gerald Schuller, and I'm a professor at Ilmenau University of Technology in the Department of Media Technology. And we are working on audio signal processing and deep learning for audio using Python, of course, right? So I really like Python. And today's talk is more like a hobby of mine, which I started about a year ago in March of last year when the Corona pandemic just started. And I did it to basically for myself to predict if I should register for a conference, which was in, I think in May or June, and wanted to know if it's still going on then, right? Or how bad it can get. And also I was involved in planning conferences in fall, and I wanted to know if it can be, if it's online or if it can be present. So for that, I developed some models, and first just in Python, and then I thought, oh, maybe it's more convenient to use some Python notebooks for it. And then I thought, oh, maybe it's good to publish it so that other people can also use it. So this is how this started. So I use Jupyter notebooks, and they're basically very practical because they're kind of a mix of documentation with code. So you can compute something like models, corona models, and you can also explain it in the same document. So for that, you use Jupyter notebooks, and they start a local server for a browser which you start in your machine. And this then displays text and also runs code in the browser. Related is, for instance, JupyterLab, which is doing things a little bit differently, but it's quite similar. Then if you want to do it not just on your own local machine, but also via the web on other machines, you can use the so-called NV viewer. That can be used to publish it, but the code is then fixed, so you cannot really change it in your browser. That's different on Binder. There you can publish it too, but also you can run the code. But this usually has a very long startup time to start a new setup. So Google basically has Collaboratory, and that's more or less experimental feature, which offers these functionalities, and it has a much faster startup. So basically it starts right away, and first it just displays a fixed page, and then if you want to change it, you can run it, and this running actually is quite fast. Yeah, so if you're in Google Drive, you can start it with new, more, and then collaboratory. So it's hidden under more. Yeah, and once you opened a new sheet, collaboratory sheet, then you can enter Python Jupyter notebooks, which run on Google servers, and that can be fast. So that's good, for instance, for machine learning, where you which might be very compute intense, right? So it's good to have those servers, and you can actually then book GPUs for it. So that's also convenient. I use it for interactive presentations, which you, for instance, can use for updating the data, updating the plots, and also zoom into plots, see some details, or select what is plotted. And they can also be saved into GitHub and published in this way. So then it doesn't stay just local, but if you want to publish it, you download it to GitHub. And then basically GitHub then is published, and then everybody who has this link to GitHub can view it. So in this way, you can publish an interactive presentation. Yeah, and the text in those Jupyter notebooks are basically in Markdown language. There you can include links, web links. You can include LaTeX-style formulas. That was, for instance, important for my models. And you can even show embedded websites. Also very convenient. Then you have so-called form cells, and in the form cells, you can actually hide the code. So that's somewhat different from the Jupyter notebooks, where you have the code, and then you have the output in the next cell. And if you have a lot of code, this can become messy and difficult to see. So form cells allow you to hide the code and just show the output, the resulting plot, for instance. You can also add inputs. So this is kind of like a graphical user interface, a very simple one, where you have, for instance, sliders or pull-down menus. You can have a date entry. Yeah, I mentioned the slider. So these are simple and still kind of elegant ways of inputs from the user. So that's practical. You can also use data processing. So you can read in up-to-date data from online repositories. Like what I'm doing here is using the Johns Hopkins University Corona GitHub repository for the up-to-date data, and then compute things and then plot them. And in the plots, I can have a hover tool, which basically tells me which line it is that I'm looking at. It has a zoom tool and so on. And that can be done using the plotly library. Yeah, and this leads me to my example here, which I have in this GitHub repository. So github.com, TOLMNO-AMS. This is for applied media systems, and then Corona computation programs. So you can go to this link and there you find a description and then a button to the Colab. And I will go to this Colab now. So this is after I press the button, I get to this page here. So here you can see, basically I'm starting with a text cell, which has the title here. And here you also have a link to the parent website. So you can click here and then it opens the parent website. So this is my GitHub website, and here you have the button. And going back, then let's see, cannot go back. Okay, here you go. Yeah, so here, when you double click on it, you can actually see the markdown language. So here, the double cross is a level 2 header. Then you have this link, which it automatically recognizes it. And then you can see here, you can have bullet points with stars, and then you get a nice layout. So that's convenient. So when you click outside, the markdown is gone. So here basically you can add explanations into this website. So here, for instance, connection to climate change, which causes shifts to habitats of animals and plants, which then leads to new encounters between animals and humans, and that leads to new opportunities for viruses to jump between species, and hence dangerous viruses and pandemics. Yeah, and here we come to the next cell. So here you can see the GitHub link, which I'm using for my plots and for my models. So when you click on this one, you can see the website from the Johns Hopkins University. And here you can see different CSV files. Like in the last talk, we saw that we can easily read in those CSV files in Python. And this is what I'm actually doing. So go back. Yeah, and here you can see the first formula. So when you double click on this text cell, you can see here, down here, you can see this double dollar sign is signaling that this is a LaTeX style formula. So here you can actually use the LaTeX formula style to enter a formula. Here it's a very simple formula, nothing fancy, but still you can use the same kind of commands. So I find that very useful. So here the first formula, which I then apply to the first plot. Here I'm computing the concurrently sick people as the total number of infected, which means this is the accumulated number, minus the recovered, minus the death. So this is in between detected infected, and then going out of the infected state by either recovering or dying. So we get all three from the Johns Hopkins University webpage, and so we can simply compute it and plot. And we don't want to do it for all the countries in the world, and that's why we here have a country selection. So here you can see we have pull-down menus, and you can select some country. So you can see the second one is fixed to Germany, and then we have the long list again. So this is also what you can do. You can have, for the different pull-down menus, you can set different sets of countries. And you can also have a date entry here. So down here you can see, or you can actually have a little calendar and choose a date. And this would be the start date. So here it's set to March 1st, 2020. And then it prints the selected countries and the corresponding populations in millions, which I'm using for the following plot, and the start date. So basically, this is the input, and the populations I got from a dictionary to make things convenient. So you can also double click on this one here, and then we can see how those pull-down menus work. It's actually quite simple. So here you simply have this keyword number at param, and then you list as an array of strings the countries that you want to list in this pull-down menu. This is then assigned to this variable country 0, and then I append country 0 to my array countries. Right, array or list countries. So it's actually quite simple. So it's actually a very simple graphical user interface in this way. Then down here we have the populations. So this is what I entered manually, this dictionary of the countries and the corresponding populations. And here I have the date field. So here I have param, and I just enter type : date, and then it recognizes that it's a date field. So again, very convenient. Yeah, here I'm using the datetime library to convert the data format, because this data format doesn't quite fit to the following libraries that I'm using. So for that, the datetime library is also quite useful. Okay, so let me close this one here again. So here you can see this one here. So this is already a form. You can actually see it here in the header display mode : form. So that makes this a form sheet. And here can actually then use form and hide code to hide it. So that's convenient. It makes it easier to operate. So then the next cell is containing a computation. Right here you can see a plot. And here you can see this is the concurrently SIG using this difference which I just showed. And here you can see the resulting plot, or the resulting plots from the different countries that we selected just above. So you can see it's all nicely color coded. Here you can see the day since March 1st, and going up to the current date. So here you can see the latest date here is April 25th. So it's yesterday, so it's actually up to date. And here you can also already see the hover function. So if I go with my mouse over a line, it shows me the country. Like here we have orange, it's Germany, and the date of this last point, which I'm hovering over, is April 25th. And we have 307,201, 307,000 concurrently SIG in Germany. right? And we can also see here we have the US, which has 0.99 million people who are concurrently sick, which means they are infecting because they're actively sick. But you can see the numbers of the US are, of course, much higher than for Germany, simply because it's a larger country with a higher population. You can see actually Brazil is even higher. So to compare different countries with a density of actively sick, which is, for instance, important if you want to travel to different countries, you want to decide how infective or infectious a country is. You want to have the density. So that's why you want to have the population. You want to basically take this number and divide it by the number of million people in the population. Yeah, but first here's my model of the virus spread. So here, this is the model I came up actually last year in March. I'm using a simple logistic model to describe the virus spread, which is this one, which is basically an exponential growth with saturation. So it saturates when basically most of the population is infected or was infected. And this is what this model is computing. And so this is often used for population growth predictions, but the virus is basically behaving like your population. It increases in the same way. So it's a simple but very effective way of predicting because it just needs a few parameters. Like this K here is called the carrying capacity. This is basically the total population. For Germany, it would be 83 million people. Then we have the P0, which is the starting population. And T is the time in days from the starting point, from the starting population here, P0. So in this example, it would be March 1st. And R is the rate. And this R is computed as the logarithm of the factor increase, which is the day-to-day factor of increase of the infected people. Yeah, and right. So for modeling the number of concurrently sick, I used a time from infection to recovery or death of 16 days and computed the difference. So this is basically looking at the data, and I found 16 days is a good substitute for actual data for death or recovery, which is often missing. So I just compute the number of infected minus the number of infected 16 days ago, and that's the concurrently sick. Yeah, and this factor of increase in the beginning was much too high. So I found if we have this factor of increase in the spring of 2020, which was like 1.25, that is basically leading to a catastrophe. So I was looking for a doable and manageable factor of increase, and I found this factor of 1.02 is manageable until about spring 2021, which is now, for which I assumed that we have vaccines, which is indeed the case. And it turns out this was actually quite a good guess, this factor of increase, which is shown here in the next plot. So here in this next plot, the blue curve shows my model for this best case scenario of 1.02, which I called possible solution. And then the orange line is the data that we already saw so far. So let me also open this this form sheet here. And you can see how it computes the things. So here I'm using matplotlib for the computations. Dates to basically handle the dates that we have in the data. And here's the logistic function. It computes it for my model. And then here I'm testing if we are in Colab, and then I'm enabling plotly in Cell for my plot. And I found plotly also very helpful because it handles matplotlib. So basically I can use matplotlib because that's the library that is mostly used in signal processing. Well, in my case, I'm used to it. So I can use matplotlib as I'm used to, which I did here. And then I can use this conversion to plotly. So that is actually quite convenient. So I can plot my matplotlib using plotly, and in this way get additional functionality in the plot. Let's see here. Yeah, so here you can see I can set a marker, and I can also set the different functionalities that I don't see it here, like this hover tool and so on, so that I get all those functionalities. So let me go back here. Form, hide code, and in this way you can see the plot. So the blue line again is this logistic model, which makes it more or less manageable. And you can see here the orange line, the actual data that we obtained. So you can see the way too steep rise in the spring of last year. Then we had the lockdown, it went down a lot, almost to the level of my model. So that was good. So basically here you can see this is kind of like a control loop. This control loop tries to bring the actual number of corona infected down to my model, which makes it manageable. And then you can see here in fall, it started to rise a lot and deviated from my model up to Christmas, where it reached a peak. So I should say this is the concurrently sick, right? So the number of actively sick people. And then after Christmas, we had the lockdown again. So it went down a lot until end of February. And then things loosened again, and now it's rising again. So here we actually managed to come below my model, and now it's rising again. So it's again following my model, which is kind of interesting. So it seems like we have a control loop which tries to reach my model here. Yeah, so which also shows that it's important that we get now the effects of the vaccines. Yeah, and the data that I'm showing here, for the processing, I'm using pandas. So for that, I should show you how I did it here. So when I double click here on this cell, you can see, let me hide the form so you can see it. So here I'm using pandas as a library for processing the data. And here you can see I'm using URL-lib request. So that's also what my previous speaker mentioned. So here's the link to the GitHub. And here I'm using URL-lib request URL retrieve for retrieving the different comma-separated variable files. So here the corona cases, which would be accumulated cases, here the recovered, and here the death. And this is for worldwide cases. So this is for all the countries. Here I'm fixing some problems with the United Kingdom, which has some extra entries for provinces and state. So to remove some overseas territories. Here I'm removing some information about latitude, longitude, province, state, and I set the index to country or region because this is what I want to plot. Doing the same here for the recovered and for the death. And yeah, here I'm resetting the index and start with a given start date. Here I'm estimating the concurrently sick by replacing non-consistent data with the 16 days that you just mentioned. So for some countries, the number of recovered and the number of deaths don't really make much sense, which I tested here. And then I replaced it by this 16-day incidence. Yeah, and here I'm starting to plot it again with plotly. So first I'm using matplotlib, and then I convert it to plotly, which you can see here. So here you can see I have the plot date, which I plot here, and then I'm using this conversion to plotly to get the nice functionality. Okay, so you can see it's actually quite a lot of code, and it can be annoying if you have so much in your document. So it's actually, it helps a lot if I hide it and just show the plot here. So you can also see, you can activate those tools. You can click on zoom, and then you can, for instance, zoom in here, and then you get a nice enlargement. So it's quite fancy, I think. And here you can do an auto scale or home if you have given access. And you can even take a snapshot. You can download as PNG, which I don't want to do here, for just storing this plot, right? So this is also quite convenient. All right. So I even have sound, since I do a lot of work with audio. I just took those two curves and translated them to tones. So you have two plots here in this case. So each plot gets their own frequency, their own pitch, and then the height here is then treated as volume, right? So here the lower pitch, I think, is the model, the higher pitch is the actual data, and the volume is how high the curves are. So let me try it. Yeah, so this is what you can hear then. Maybe in this case it's not so helpful, but sometimes the sonification is helpful, for instance, for hearing synchrony. So the ear is very sensitive for synchronous events. And I can click on it and show you how I did it here. So here I'm constructing sinusoids. And here I'm writing them to this file using WOF write. So here scipar.io WOF file is used as the module as WOF. And then I'm writing to this WOF file here. And then I'm using audio to generate this playback functionality here in the script. So it's kind of nice. And this audio comes from IPython display, right? So IPython has this audio button already built in, so you can use it for playing back sound. So it's kind of a nice functionality. So let me close this form again, or this code. Yeah, and then here we have dimension concurrently sick per million. So this is how infectious different countries are. And you can see you have Germany, it's like kind of in the middle. Then Brazil is about twice as much. Italy actually also has quite a lot. And then we have Lebanon. Then here in the US, you can actually see that the vaccinations they have seems to have an effect here. It actually went down. You can see here in the United States, it reached a peak around January 15th. This was actually about the time when the new president was sworn in. And after that, it went down a lot. So the new policies of Biden seem to have a big effect, and also the policies of distributing vaccines quite widely seems to work. So that's nice. Otherwise, it seems goes up, particularly in Germany it goes up, and in Italy and Lebanon it goes down. So this is kind of nice to compare different countries, also to see what's going on internationally. Down here, by the way, is South Korea. And South Korea, they have, it seems, a much more effective way of dealing with this, with the virus. And they have a very low growth rate. And actually, I came up with a 1.02 growth rate by looking at South Korea in the beginning of the pandemic. So they really know how to handle a pandemic. So they are quite skillful there. Much better than we are. They were also the first to employ widespread testing. So actually they developed one of the first corona tests. Yeah, looking at those plots, now you can actually also use Matplotlib for zooming in, and here I could also add some text into this box, and because this is fixed, I just left it in Matplotlib. Here you can see the effect of the corona measures, the shutdown, in April of last year. So you can see here, start of Germany's corona restrictions, end of March, and then about a week later, you can see how new cases decline. So this is the number of concurrently sick, so actively sick people here, and you can see it's actually quite effective. Similar for other countries, like here, Spain, here the US. And you can see we have the same colors here because even Plotly uses Matplotlib as the basis. So I found that also helpful when I have different plots to have at least the same colors for the different countries. Yeah, so you can also easily compute the 7-day incidence, which lately became the most widespread measure. So the 7-day incidence per 100,000 inhabitants. So here you just take the current number of infected minus the number 7 days ago, and divide it by 10 times the number of million inhabitants. And then you get the 7-day incidence per 100,000 inhabitants. And this also allows you nicely to compare different countries. So I found that practical. So here, Germany, currently 180. Then here, Brazil, 189. So it actually went down a little bit. Then Lebanon went down a lot here, from over 300 down to now 153. Then Spain also improved. And South Korea currently has 9. So this is actually quite a big difference between Germany, 182, and South Korea. I should also mention the data from the Johns Hopkins University for Germany is somewhat different from the Robert Koch Institute. And that's because they have slightly different databases. So, but I found they differ about 1%. So that's usually much better than you need for those models and predictions. So as with every measurement, you only have finite accuracy, and so you might have slightly different numbers, but that's okay. That's normal. You also see some data problems here for Spain. So negative numbers here don't really make sense. So there's some inconsistency in the data they have here, which you can also easily discover when you look at those plots, at those time plots. Yeah, and you can also compute the so-called under-detection rate, which is basically the number of cases that you didn't discover using testing, right? So, you know, you only capture a certain number of people who are sick and you miss others. And you can actually easily compute it or estimate it by looking at the case fatality rate, basically the number of people who die who were tested positive before, divided by the infection fatality rate, which is the number of people who die from all infected, including the ones which are not detected. So this infection fatality rate actually differs depending on the age distribution of a country. And I found for Germany, 2% seems to be quite fitting. In general, it seems to vary between 0.6% up to about 5%. So using the 2% here, you can easily compute this under detection rate, because the case fatality rate is given by your data, right? You just take the number of deaths and divide it by the number of deaths plus the number of recovered. These were the ones who were detected positive before. So this gives you the case fatality rate. So if you then take this case fatality rate divided by the infection fatality rate, you get the under detection rate. So this is kind of nice to give you a measure which is independent of testing and compare different countries. So you can see in the beginning of the pandemic, you had very high under detection rate because testing was very bad. And then it became better over time. So you can see it. Germany was actually quite good, quite early on. South Korea was even better quite early on because they were the first who had tests. And you can see here when you zoom in, recently they are all pretty good. You even have some which have factors below 1, and this comes because those countries have infection fatality rates below 2%. So then this estimation doesn't really work so well anymore. So this is actually true also for the US. So this happens usually for countries which have a relatively young population. Here you can see Germany, which has kind of an old population. We have this factor of 1.36. And also this 2% fits to us. So for Germany, this is a more precise number. So that means basically we have 36% more people who are sick than we have detected. But that's basically a very rough estimate. It can easily be a factor of 2 or more above or below. Yeah, and we can apply this factor also to the concurrently sick, which I did here in this plot to compensate for the different testing in different countries. So I want to skip this here. You can also compute the resulting death cases per million inhabitants. So here you can see it. Also, you can see here, Spain is kind of odd. So they have some data inconsistencies here from Spain. Germany was bad in the beginning of the pandemic, but during the summer it was pretty good. So you can see very low death rate. But then in October, we had a steep rise until we had this maximum death rate in early January. So that actually came about 2 weeks after the peak in at Christmas time. So you can see the death rate is already shifted by about these 16 days, which I assumed in the beginning. Yeah, and now you can see that Germany here in this second wave is kind of like average. It's not really like some of the best like we were in the summertime. And fall became kind of average. And here we can see Brazil actually has a high peak here. So this is also compensated for the inhabitants because it's per million inhabitants internationally. So Brazil has a problem here, we can easily see. Yeah, and we can also plot it as the accumulated death cases per million inhabitants, and you can see we get more smooth curves. So they're actually more easily to see when you have the accumulated cases here. It's much smoother, easier to see than the weekly average of the death cases. Yeah, and here you can see Germany came kind of average. So during the summertime, we were on the low level compared to, say, the US, which was steeply rising. But here in the fall, now we actually on the same level roughly as Lebanon. Yeah, here also a little comparison to influenza, for which I have some links included here. So when you have the influenza, often the excess mortality is used, and in a heavy influenza season, we have about 200 deaths per million, but that also includes other causes of death, like car accidents, for instance. But confirmed influenza deaths are only 20 deaths per million. And so this confirmed death is more suitable because COVID-19 deaths are also confirmed death. And Germany and the US already surpassed this 20 deaths per million already in early April of last year, right? So that's quite a big difference. Also for the seasonal flu, we already have vaccines, so we don't need to worry about it that much. Yeah, for the death cases, the accumulated death cases, I also have a model. Again, we can use a simple logistic model, which we can see here. So blue is again my logistic model for the accumulated death cases. And I found here at the end of the model, which was the beginning of April, it actually coincided with the true number of deaths. So it was actually a very precise coincidence here from my model with the true number of accumulated deaths. So kind of interesting coincidence here. But again, you can see it's hovering along my model here. So this model was actually quite helpful. So it helped me to determine that this pandemic lasts at least a year, already last year in March. Yeah, and to see on what trajectory are, I computed this increase factor of the concurrently sick. So when it's larger than 1, we have an increase, less than 1, we have a decrease, and a constant value of above 1, we have an exponential growth, similar to a fire that spreads. So here you can see it. So again, Spain has some outlier here. We want to be below 1 and at least below 1.02. So we can see currently we are just below 1.02. But still above 1, so it's rising. Whereas here in Italy, it's below 1, Lebanon is below 1, US is even less below 1, and here Spain is also even more. So below 1 is good, above 1 is not good. Right, so here now I have a slider. So I can use this data to predict, say, the next 60 days. And here I can use the slider to select desired number. So for instance, here, set it to 60 days. And as with all the other changes, if I change something, I need to rerun the model. So here I do this by clicking on runtime in the Colab and then click on run all. Then it starts to compute from the beginning. So then here you have to click on run anyway. And then you can see at the bottom here, a progress bar, hopefully. Okay, so now it's doing something. You can see it's processing. And here in the bottom, you can see executing. So you can see some progress. And it now basically recomputes the entire set of cells that we saw from the beginning, because one depends on the previous. And you can see the computation might take some time, but you can see it's already done here. So now it computed this plot, and here you can now see the prediction for the next 60 days. I should also show you how I implemented it. So here, again, the logistic function. And here is the slider. So let me close, let me show you the code, hide the form. So here you can see, it's very simple, type : slider, And then you can see set the minimum, the maximum, and the step size. Here's the default value, and that's then stored in the variable prediction days. So basically, you just need to have this one line to have the slider as a graphical user interface. So very convenient. So hide the code. And then here in the next cell, in the next plot, you can see the output. And it basically comes from the growth rate. You can see here, Germany is rising too fast. Here, South Korea is fairly stable. As you can see, Lebanon is decaying. Yeah, you can do the same here with a true concurrently SIG, which includes the under detection factor, but in principle it's the same. So I'm going to skip it. Interesting here is my last entry, which is a website, an embedded website here about the vaccination rates. So here you can see the website, and I want to click on it to see, to show you. So here I have a iframe, right? And this iframe means we have this embedded website here with a source. So that allows you to basically display this website in my document and also with full functionality. So I found that also very convenient. So I'm gonna hide it, hide the code. So here you can see I have a window inside my cell. And this window then is this website with the vaccinations. So you can see it here outside. I have the slider for my document, and then inside slider is for this website. So here you can see I have the metric people vaccinated, interval cumulative, and here relative to population. And here you can compare now different countries, which I can select here. So for me, it was very convenient because I could just take this website and embed it. Basically, all the desired functionalities already built in. So you can see Germany is kind of in the middle field here. We have currently 23% people having at least one shot of the vaccine. We are a little better than France and Turkey, and much better than Brazil or India. But we are worse than the United States, right? The United States currently has 41% having one shot at least. United Kingdom 49, and Israel here even has over 60. Right? You can also include the world. So world. Yeah, so now we have the world in it. You can see here the world is actually quite bad, 7%. So it means we are actually above the world average. Yeah, you can also select different ways of presenting it here, but that's part of this website. Yeah, so basically that's the end of my talk. Yeah, and I'm open and curious about questions that you may have.
Yes, Gerald, thank you for the great talk. Yeah, if you have a question, just write it in the Twitch or in the Zoom chat.
Okay, thank you, thank you.
Thank you again. I think the talk was very insightful, and apparently nobody can think of a pretty specific question. But for me personally, it was very interesting to see all the data and how it could be easily visualized with this tool. And yeah, all right.
There's one question I'm seeing from Jessica. I'm wondering about this sonic analysis. Is this something you have done for other projects? Well, not really. It's more like an idea. It's also an idea that's going around in the audio community to use sound for sonification of something. Like, for instance, in this way, you could discover connections, correlations, synchronies between different data by using sonification and your ear, because the ear is more trained for looking for correlations and synchronity than, say, your eye. So I found that interesting. So here in this example, it didn't really help so much, but it's kind of interesting to think about this possibility. Yeah, you mentioned you can hear harmonities. Yeah, for instance. Yeah, thank you.
Thanks again. So what follows now?
There's two more. Are there studies promoting sonic analysis?
Oh, yes.
Would be nice, right? But I'm not aware of any. Yeah, I like how you incorporated different ways to look at the data. Right, yeah. Often having different angles to look at the data helps a lot understanding data, like I did here over time. This is one dimension, and across the world, comparing different countries. That also helps to get a different perspective. So I found that very, very helpful too. Okay. Any more questions? From Twitch, maybe? I can see Twitch.
No, not so many questions. They asked for links, but I shared, as you shared them in the Python event, so you can also see all the links and information about the talk in our meetup event. So feel free to go there and check it out. Thank you so much. It was great. I also really like this idea of analyzing the sounds. That's like 5 cents from my side.
Yeah.
Thank you so much.
Okay, thank you.
I would like to thank all of you once again for coming to PyBerlin, and also special thanks to Cheuk and Gerald for speaking today at PyBerlin. Today's event is sponsored by Scoutbee, so thanks again for the premium Zoom account, and also thanks, of course, to Manning and all of you. Even if you didn't win the raffle, can still go to this link on the Manning webpage and use this discount code to get 35% off of the book of your choice. The next meetup would be on May 21st, on a Monday. We are always looking for people to help out, so if you want to reach out to us, any help would be really welcome. We are also always looking for people to speak at PyBerlin, so if you have any idea, don't hesitate. Just has to have a connection with Python, and then it's eligible, so feel free to submit any ideas. And you can use the form on this short URL to do so. Also, don't forget to follow us on Twitter and tweet about us.